Well, here we are at ATXSG. I'm Ben Wadecki, and I'm really pleased to be joined by Ajima-san, Chief Evangelist of KDQ Business Development Office at Toshiba Digital Solutions, and Chung-Yung Lam, Co-founder and CEO of Spectral. Both of you, thank you so much for your time. Welcome.
Thank you.
Thank you.
I'm happy to be here.
So we're talking today about securing the future of the quantum economy. Now, it's a huge topic and it's got huge ramifications. But Ajima-san, let's come to you first. You actually just came from the stage talking about this very topic. What did you talk about on stage?
In a nutshell, I walked through Toshiba's vision of quantum economy and accelerating momentum toward the vision coming to the truth and the reality, and how momentum will bring about host of the benefit and threat. Then Toshiba quantum journey, then research to the reality over the past few decades.
So what do you see as Toshiba's vision being for the quantum economy?
Well, we believe the future will be defined by quantum computers and the quantum economy. So what is a quantum computers? Quantum computer is not a natural extension of the current Moore's law. Not just how light bulb was not a powerful candle, was not for T model a powerful hose. So quantum computer is a new kind of technology that will fundamentally change the quantum economy and our society. Most importantly, they will change the security and the encryption landscape. So we foresee huge potential for the quantum economy, much greater than digital economy we see today. And the many sectors require fast, secure, and reliable transmission of data, including government sectors, financial sectors, healthcare, telecommunication, utilities, infrastructure, and name a few. So against this backdrop, the rise of supercomputing will challenge the security of existing encryption method, exposing vulnerabilities and security risks in this data-driven world.
So the important thing that you touched on there was talking about the threats and the potential cyber issues. The joy of quantum computing is the level of security it provides. Now, obviously, we're still a way off from achieving that, but in the meantime, it's providing a really important offering in the future for threats. What kind of threats do you see that it can impact, and how are they going to affect brands, businesses?
So by 2025, Gartner expects 40% of large companies are planning to create an initiative around quantum computers. So with a quantum computer coming sooner than you think, this security issue will never be more pressing. The threat we are seeing today is from harvest and decrypt attack, which put today's critical data at a very significant risk. So many types of information must stay confidential for several years and even for several decades. However, it's easy to collect and store encrypted data now and decrypt data later when more powerful computers are available in the future. The long-term confidentiality is already under threat.
So, so Ajima-san, on that, how do we go about managing those challenges?
Much of the current today's cryptography is based on hard computational problems. So security rely on the fact that it takes long time to solve those problems. However, quantum computer is able to solve those problems efficiently. That's why new techniques are needed today for long-term confidentiality. New crypto technique, which cannot be broken by quantum computers, are needed. So that is where the need for quantum secure communications comes in. By leveraging quantum key distribution technology, which is known as QKD, to overcome those security challenges. And QKD technology is fundamentally building a quantum safe network that everyone can rely on. And Toshiba has invested and researched QKD technologies for the past 3 decades in UK research lab. And to date, we have invested millions of dollars in R&D in the UK and Japan to realize the world's fastest key distribution in a real world environment. So in fact, Toshiba holds most patent of QKD related globally. That is where we are.
So, Chun, I want to bring you in on this, and I hate to ask you this question, but how does QKD work?
Yes, QKD, or quantum key distribution, is a means to deliver very securely symmetric encryption keys to two parties. That is backed, the security is derived from the basis of physics, the laws of physics and quantum mechanics. As opposed to the current key distribution techniques, which are software-based, quantum key distribution, literally embeds information in single particles of light and relaying these individual particles of light called photons from user A to user B. And in such a way that we are using the quantum properties of this light. And if there's an eavesdropper that tries to intercept these signals while they are in transit, when they are flowing from A to B, Alice and Bob, as we call it, they would know that that signal has been tampered with and has been compromised. So this means of using quantum key distribution is absolutely safe against eavesdropper. And once Alice and Bob, the two parties, have that matching pair of symmetric keys, they can do encryption and decryption using those keys, and those encrypted information will be safe from any future attacks from a quantum computer.
That's really important. Again, it really highlights the security aspect that Ajima-san touched on earlier. I want to ask you, because obviously we're here in ATXG in Singapore. Would attendees here today be able to acquire and use QKD in Singapore?
Yes, definitely. So it's with Toshiba and the industry-leading QKD systems that's been developed, we are ready to provide QKD solutions to users, enterprises, and customers here in Singapore right now. In fact, we've been talking to a number of stakeholders, a number of potential users on deployment of QKD solutions across their various sites.
So what kind of verticals do you see as being the kind of early adopters for QKD technologies?
Yes, the way to think about QKD is that we are securing essentially the information or data flow that are of high value or large value. High volumes and high value, right? So basically, if you think about communications between government agencies, defense sector, or critical infrastructures, this would be prime, because the information is very, very sensitive. Next up will be, I would say, data centers, where they're handling huge volumes of information, and obviously the financial sector as well, where the transactions are of high value and it needs to be absolutely secure. So we see these verticals are as kind of one of the earlier adopters of QKD technology.
And one that I'm aware of is the satellite aspect. Now that's really growing with the growing kind of communications and connectivity aspects. What do you see as the kind of outlook for satellite QKD?
Yes, definitely. I think one thing we came to realize is that while a lot of information and businesses and data flows are happening within Singapore or within metropolitan areas, right? Connectivity or communication today is global in nature. So, interbank transfers between here and New York or London, intergovernmental communication, data centers and cloud providers moving data around the world. So that's where Spectral, has a sharp focus on delivering QKD via satellite, and that ties in very well with the fiber-based QKD deployment that we are doing here in Singapore and Toshiba elsewhere and other parts of the world. And the ideal scenario is that once we have local QKD networks being set up here in Singapore and in other major cities, we can leverage the satellite-based QKD to connect all these major cities and encrypt or secure all the information flow or data flow with quantum key distribution.
I look forward to seeing that in action. One thing that I will ask you both before we round off today is, how important is it that QKD technologies are kind of the early adopters and the early kind of trendsetters for quantum realization? Because this is really important to showing the true realization of quantum technologies. How integral is it that QKD gets off the ground early and is doing as well as it is?
Yeah, I think it's really pertinent that the early adopters, pave the way and show the major use cases of QKD technology. Just for example, in Toshiba in the US, jointly with JP Morgan Chase, they've demonstrated QKD using QKD to secure blockchain applications. Similarly, I think a lot of the governments and the defense and critical infrastructure sectors, they are really primed to kind of move forward and integrate QKD, secure communication within their communication infrastructures. So we need all these kind of prime examples, and we are continuing to develop use case applications across all the various verticals as well, and that will come, in sequential stages as we go along.
Well, let's look forward to seeing more of them in action. But until then, thank you so much for your time. Thank you kindly.
Yeah, it's a pleasure.
Thank you.
Thank you
both.
so much.
Thank you both.
Cheers.